Hello everyone. TechGoodReads give you good thing to read to listen. Today I will talk about aspect-oriented programming used in system design. First, let's look at object-oriented programming. OOP is widely used and it encapsulates the code into classes, modules. But when we build services, we still see many things like logging, transaction management. Those code are duplicated, scattered in the whole code base. For example, for an API, we may want all the APIs have a exception handling, and those logic are similar, but we need to add those code in every methods. Can we reduce that complexity? The idea to solve such a problem is AOP, Aspect-Oriented Programming. It complements OOP by providing another way of thinking about program structure. The key unit of modularity in OOP is a class, whereas in AOP, the unit of modularity is the aspect. How can we understand aspects? Aspects enable the modularization of concerns. For example, we may only consider logging for each request response. We may also have the transaction management. All those specific areas require aspects. After introduce the AOP, then the system architecture changed from the OOP only to the OOP plus AOP. We can see in this diagram that the layered software has different layers: presentation layer, business layer, data access layer, but all of them have the logging and the transaction management, data validation. All those things can be abstracted into the AOP. Let's see how to use that AOP into the system design. Here we take the microservice as the example. For the microservices, and each microservice handles one specific functions. Like in this diagram, user service handle all the user related functions and provide a REST API to the outside, same as the older service. For each microservice, it has maybe several APIs exposed to the outside. We may require the similar functions on each methods, like privacy checking, data validation, logging, all those common parts. In such a scenario, we can apply the aspect into it. We can see this is the client server model, and at the server side, we have the AAA aspects. This means that for every methods, we will check is AAA. Also, we can having logging aspects and or other aspects at the server side. For the client side, we also need to do some security checking. We can also at the client side do the similar aspects there. In this way, both client side and server side API are protected with the securities, and for each new client's APIs, we don't care about those security aspects. For the AOP, a common trap we need to understand and or avoid is a callback loop. For example, in this microservice, it has an aspect. Maybe it's just for the security checking, and it will delegate this, and the aspect will delegate this responsibility to check an object. However, the object calls back the microservice to do the actual work. In this way, it produces the callback loop. In this scenario, maybe we need to break such a loop in the aspects. Maybe we can using the states to check that if the APIs is already called. To detect such a callback loop and solve such problem, we may need to simplify the aspects code, not calling the objects, or maybe if it's required, we can have some states to indicate if this API is called by any methods, then detect if any loop is generated. That's all for today's contents. Thanks for watching. This is Shiny. See you next time.